Then we'll see
All
how
right.
silly I look.
All right. Now I'm privileged to have a short talk with Bud Warren of Gear Drives, and he's a Texan. You can tell it as soon as he starts talking. And the neat thing is he's come up with some wonderful PSRUs, gear drives for automotive engine conversions, including a replacement for the Eggenfellner G3 version, which is one that I'm particularly interested in. So, Bud, one of the things that was most impressive in the forum I heard you talk about is how you designed the gears themselves, the materials, and the housing, and essentially the quality and the strength. Tell me what you what you did and why you did it, as far as the construction of the PSRU.
All right. Having a background of building equipment for people and so that, I've learned through the years basically what would work. Although my first attempts were not very good. Airplanes have unique problems, and it took me a while to work them out. Now with my Gen 3 replacement, I used all the features I have in my big drives, and consequently I had no trouble with it. The first one went perfect, and it still runs perfect, and so we made a production run of them. The only difference in them is the production runs are pretty. The first one looked like a shoebox, but they're a direct replacement as far as weight is concerned and length, and so you don't have to change your airplane around.
That's good.
All right. As far as materials, I use premium everything. I realize that mine costs more than other people's, but I think mine's a much better product. I make heat-treated stainless steel shafts that are heat-treated to 195,000 pound yield, so you'll never be possible to break one, even if you don't know what you do to it. It doesn't have a fatigue life to worry about it wearing itself out. My cases are made out of 6061 T6 aluminum, heat-treated, and they're all CNC machines, so every one of them is exactly right in their precision. My gears are all are custom-made gears. I only use one brand that I have made, and so I can control the quality of it. And I can also provide whatever ratio you want in the small gearbox, anywhere from 1 to 3 to 3 to 1, which is ludicrous, but I can do it. I'm the only one who's ever built a gearbox for a propeller drive that is positively oiled. Instead, they all rely on splash or a grease job or something.
So you have an oil pump built in?
Yes, I have a built-in oil pump and a built-in oil filter. And all my bearings are roller bearings, no ball bearings in them. And they're all pressure fed, even though the ones in the bottom that set in oil are still pressure fed. So because I found that through the years that sometimes the centrifugal force of the gear will throw oil away from the bearing, and it'll end up being dry, even though it's in the bottom. So I can't have a dry bearing.
Right.
And my propeller drive will accept anyone's problem. Anyone's. I don't care. I don't have a qualifier. You can even put a constant speed propeller on it without buying any extras. When you buy one from me, it comes fully equipped. There's nothing else to call and buy.
Okay.
You can put whatever you want in it. Electric, fixed pitch, ground adjustable, hydraulic, electric, anything. If somebody makes a propeller, it'll go on my deal.
Okay, well that sounds good. Specifically, you use spur gears, as I understand it, not bevel gears?
That's right. Spur gears are straight cut gears. They're not necessarily loud, but they are necessarily the strongest gear. And if you look in engineering books, the spur gear makes better tooth contact all the time, and your tooth is beefier and so consequently stronger. I'm doing everything for strength.
Right. And then that means you don't have side loads that...
Yes, that means that your gearbox doesn't have to have side loads or end loads in order to destroy bearings. If you build one with slanted gears in it, you have to build it. Consequently, if you build a good one, it must be much heavier, because you have to build your end plates much heavier, and you have to use tapered roller bearings on either end of your shafts everywhere, and consequently your weight has to go way up. The way we do it, they're straight roller bearings, except on the prop where it's tapered, loaded fore and aft, but all the rest of them are flat. So they don't have any thrust to worry about. So you can make your case lighter still with making it still be strong.
Right. So the roller bearings have a line contact, a much larger contact, where your ball bearings point contact. So
That's right. They'll have like 10 or 15 times the load capacity of the ball bearing will.
Right. That's impressive. All right. And then this box can run cool. I understand. I know you talked about testing it on the ground and seeing how cool it ran.
Yes, we ground test them. Every gearbox I make, we put on our old test mule. We call it Frankenstein. It's an old 350 Chevrolet. It's a homely old thing, but it runs good. We put even the Subaru box on it, and we've got a Macaulay prop, big club, off of 250, my mind went blank. Anyway, a 250 horse airplane engine.
Right.
And I load it down as much as the old engine can pull, and I let it run a while. The gearbox running in the open will show less than 120 degrees temperature.
That's just in the open without specifically blast cooling it? Or
well, it's just sitting out there.
It's just sitting in the open?
It's just sitting there, yeah. Sitting in the open, it'll run 120 mostly. All right. In an airplane, if you don't provide some cooling for it, some air across it, it will get hot. But it won't ever go across 200. Although I like to keep my temps low. The Chevrolet one flew up here from Houston, and the highest temp I saw was about 140.
Right.
Because I had some air across it.
And on the Raven that you flew, it looked like you had just had 3 1-inch holes.
That's right.
For the cooling on the PSRU, and that's all.
That's it. I just drilled 3 holes under the spinner, 3 little holes about an inch diameter, and that's all you need to do. It runs cool from that point on.
Well,
if you don't, it'll show about 200 degrees.
Right. Well, that's impressive too. So we've got, the thing about the bearings, the quality of the materials, how hot it runs, etc., and the fact that it's a direct replacement for the version G3 propeller reduction unit.
Yes.
So any other particular features that you've been into it other than the fact that, of course, your full flow oil filter to make sure that your oil is always clean? And I think you said something about you definitely don't recommend synthetic oil for this box.
And I've had people argue with me, but anecdotal evidence proves that I've tried all the major brands and they all run hot.
Right.
And when I take it out and put mineral oil in it, it doesn't. So I just tell people I won't support it if you use synthetic oil in it.
Okay.
It's cheaper to run the other, and it works well. So I just, and although I've had people argue with me, I won't argue about it because I've already done it. I know what it does. I couldn't tell you why, and it doesn't make any difference to me at this point why it does. It just does. So.
Well, you've tested it. That's the important thing.
Yes.
Overall, about how many hours in the test mule have you run that the one for your gearbox you make for the Subaru?
Well, I'll tell you what I did. I built the first one we call a shoebox.
Right.
I put it on a 350 Chevrolet, and I run it 40 hours continuous, other than shutting it down and putting gasoline in it.
Right.
At the end of 40 hours continuous, under way overload of what you'd ever use on it, it showed no signs of wear. So we put it on Larry's airplane.
Okay, Larry, who is this person?
Larry Perriman.
Larry Perriman. He's been working with.
He's my associate, and he's had
right.
He had the first Subaru flying in Texas, I believe.
I see.
It's been around a long time.
Right.
With the Eggenfeldner. So
right.
He's went through Gen 1, Gen 2, and Gen 3.
He's done all of them with
He
eggs.
didn't run the Gen 3. He got it. And we fixed his deal, and he just sold his Gen 3.
I see.
Okay. So he hasn't run his Gen 3 personally, but I've seen them, and I've seen what they do.
Right.
That's the reason I built this. People used to come to me all the time and say, please build one.
Right.
Because the one we got is not good. So I finally did.
Well, that's impressive. So basically, when you buy the unit, it comes with everything you need: the special spacers and the directions.
Everything.
So that you can.
It also comes with my clutch.
Oh yes, we got to talk about this clutch that tames the torsional vibration
yes, sir.
Monster for a lot of people.
Yes, sir. It looks heavy, but if you'll find the plywood you take off weighs a couple more pounds than mine does. So it's not weight brake penalty. All right. It also disengages after you shut the engine off, and it doesn't engage again until you start the motor. So it makes it easier to start the engine, one thing, and it spins just behind the engine. Once it starts, boom, you never know any difference. It cannot disengage in flight. It'll also make your airplane run smoother. And while we're talking about running smoother, yesterday at Forum, I explained it's very cheap, very easy to do, how to take the strumming noises out of Subarus, which most people experience.
Oh yes, you've mentioned that. Explain the supports you recommend on the rear of the engine, or the rear. It's actually the front, but the back side of the engine.
Yes, as they mount most of them, I've never seen them mounted different. They mount them from the engine flange on a plate.
Right.
And the plate, the engine is unsupported on one side and the drive's unsupported on the other side. And when it runs, when the prop comes on downstroke, on its bike circuit, it makes the motor wobble. You don't see it wobble, but it does.
Right.
And that's why Larry used to break oil coolers and radiators when he had his little radiator on front. So
I see.
We just made a little bracket that runs from we couldn't find anything else on the four cylinder to mount it to, except the two of the exhaust flange bolts. We just put a strap back or cut out of a piece of angle and run it back to the back edge of the engine, get it back there, and then in the flat part of the plate you drill about a 5/8 hole, and you go to the parts house and buy shock bushings off of car shocks, and you put you an upright with a bolt. You can weld it together and put it down to one of your tubes of your frame, and make a little saddle. Split a piece of tube and make a saddle and weld that on there. Don't weld it to your airplane or anything. Just put that saddle on there with one stainless steel hose clamp.
Oh, okay.
Just one stainless steel hose
So
clamp.
a saddle with a hose clamp to the engine mount.
Yeah, to the engine mount, somewhere in best you can in line with this part. Okay.
Right.
And then you just weld a long threaded 3/8, 24 or whatever bolt on there, and you put a washer. You put your bushing. You put your bushing on the other side and a washer on top, and tighten it down till it just snugs it.
All right.
Don't compress it much. Just take the slack out of everything, just like you would on a shock absorber. That's all you have to do. You should do one on either side. You'll find your airplane, instead of going strum, it goes hums along. Your floorboards won't be jumping, and you won't be wearing out your airplane.
Well, that's a good tip.
Almost nothing.
Right.
You know, you can do it yourself. You buy 4 other bushings.
So the angle doesn't have to be very thick steel. You're talking about 1/8 inch angle or something
yeah,
like
1/8
that?
inch angle, you know, and just don't make it real heavy. It doesn't have to be real heavy.
Just want
It can't make it out of flat strap because it won't do anything. It'll just
right. So you need the stiffness of the
yeah,
angle.
you need a little bit of stiffness angle, and you can taper it off. You can make it pretty. You can do all kinds of things. But the idea is to run it back as far as you can to give the motor some balance, because the motor is sitting there unsupported, and that's why they go in and out of frequency.
Right.
And so Larry's used to jumping up. It scared me. His floorboards about to put your feet asleep if you flew very far. And you do this now, and it goes hums along. It's a much more pleasant flight, and it's a lot easier on your airframe. And everything that jumps up and down detracts from going forward.
That's right. It's wasted energy.
You have X amount of energy, and all of it wasted from jumping up and down does not let you go forward as fast. So it's an economy measure also.
Great. All right. Well, we've covered, I guess, most of the basics. Bud, thank you a lot talking to me here at Oshkosh, Friday the 30th, and I'll be looking forward to talking to my partners and my EAA chapter when I get home.
Thank you.
Thank you.
Thanks for talking to me.
Right, sir.